As we get started today, let's go and drill over our sum and difference identities. Jamie, we are praying that you will get feeling better and rejoining us very soon. If you're able to drill with us, you can drill our sine and cosine, sum and difference identities, class. Sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. And then, let's do that again just a little bit faster. Sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. One more time really fast now that we're warmed up. Sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. Yeah, you cheater. You just sine, 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 sine. Loser. All right. And what about the tangent sum difference identity? This one's a little harder to, it's not like an easy way. We'll go through it anyway. Tangent plus or minus tangent all over 1 minus plus tangent tangent. Let's start again. Tangent plus or minus tangent all over 1 minus plus tangent tangent. And so you are using those identities to do page 116, number 8, also to find the cotangent of 105 degrees and the secant of 285 degrees. Let's start by finding the cotangent of 105 degrees. And the first key is to rewrite the 105 degrees as a sum or as a difference of two angles. And what two angles did you use for the 105 degrees, Ethan?
Wait, what? Say it one more time.
To rewrite the 105 degrees,
What angles?
what two angles did you put together to make up 105?
135. 60 and 45.
That to me is the easiest combination, right? I assume most of us use 60 and 45.
Yeah.
Could have done 135 minus 30. However, remember we said for anything related to tangent or cotangent, I want to avoid the 30-degree angle. It's just going to be messy. So using the 60 and the 45 works great here. However, this is cotangent. It's not tangent. So instead of tangent plus minus tangent all over 1 minus plus tangent tangent, it becomes what, Quentin?
1 over...
Ooh.
Okay. So 1 minus tangent tangent all over tangent plus tangent.
There we go. Since we have a plus, we'll have the minus here and the plus here. It's tangent plus tangent in the bottom and the 1 minus plus tangent tangent in the top. Of course, we'll drop in the 60-degree angle, the 45-degree angle, and the 60 and the 45. And of course, we know that the tangent of 60, class, is?
1.
Square root of 3. And the tangent of 45, 1. And so when we get to the tangent of 60, we again put, and in place of the tangent of 45, 1. Now, of course, 1 minus the square root of 3 times 1 could just be rewritten 1 minus the square root of 3. And we've got this two-term radical denominator that always comes up when we're messing with tangent stuff. So I've got to multiply class by the conjugate, which is what, Chris?
Square root of 3 minus 1.
And so in the denominator, we've got this sum and difference, or this pair of conjugates, that we would do what 3 things, class?
Square the first, square the last, minus 9 between.
And when we square the first, class, we get?
3 minus
We square the last?
1.
We put a?
Minus.
And so what is 3 minus 1?
2.
It basically just becomes 2. All right, then in the numerator, I've got these two binomials we need to multiply, and usually we multiply them using FOIL. My first?
Square root of 3.
Outer?
-1.
-1. Inner?
Negative 30.
Negative square root of 9 or negative 3. And last?
Square root of 3.
Negative square root of 3. So we can combine the square root of 3 and the negative, excuse me, positive square root of 3. Negative times negative positive. Square root of 3 and square root of 3 to get?
Square root of 3.
Ooh, careful. 2 times the square root of 3. And then negative 1, negative 3, negative 4. And we're going to divide all of that by 2 to get what final answer? And how many had this value, which is, I guess, like approximately negative 0.26, blah, blah, blah. But we got this value?
No. I found the cotangent of 45 to be -1 and the cotangent of 60 to be square root of 3.
That's not how we do it, though.
Yeah. I forgot how to do cotangent.
Does it make sense now?
Yeah, it makes sense.
All right, questions on this? All right, let's take a look at the next one, which I think was the secant of 285. Is that right?
Yep. I think I did this one wrong too.
Oh, no, we're not supposed to do them wrong, Chris. Gotta stop that.
Give me back my baby.
For real. All right, secant of 285.
How would you do that?
You already eat it?
Yeah.
Yeah, that's much.
Never mind, I don't want it back. All right, secant of 285. In case you can't tell, Jamie, Chris erased the board for me. Do you see his name up there? Yeah, very nice. All right, except you only sent Chris instead of Christopher, but whatever. All right, secant of 285, and don't hurt your hand, Christopher. 285, how do we have to write 285?
I did 240 and 45.
Sounds good to me. 240 plus 45, or 225 plus 60, or 315 minus 30. I mean, there's a lot of different ways to put it together.
Well, 135 work?
135 plus 150, absolutely. All right, so again, a lot of ways you could do this. It's just up to you. Anyway, once we've got it this way, or whatever way we do it, we need to think of the secant sum difference identity? No.
Cosine.
Cosine, right? But it's going to be all under 1. So cosine's sum difference identity.
Cosine,
Sine, negative, since I have a positive. Sine. It sounds like all of you also had a plus. All of you would have had a minus here. Again, if you did 315 minus 30, you would have put a plus right here. And we drop in the angles 240 and 45 and 240 and 45. Now, the advantage of using a quadrant 1 angle as one of yours, either a 30, 60, or 45, is that you don't have to think of the quadrant for everything. So 135 and 150, on both of them, you got to think, okay, this is quadrant 2 ASTC, right? I don't have to do that for the 45, only here on the 240, which is quadrant 3 reference angle 60. Again, if you were doing 135, that's quadrant 2 reference angle 45, and then 150 would be quadrant 2 reference angle 30. What is the cosine of 60, class? Yes. And quadrant 3 cosine is?
Square root 2 over 2.
No, cosine is?
Negative.
All right, and then of course cosine 45, we don't even need to think about a reference angle there.
Square root 2 over 2.
Square root 2 over 2. And then we have the minus sign here. And sine of 60.
Square root 3 over 2.
But in quadrant 3,
Negative.
negative. Square root of 3 over 2. And the sine of 45.
Square root 2 over 2.
Square root of 2 over 2. I guess for those who did it the other way, let me show this initial step here. If you had the, was it 135 plus 150? Is how you two set it up? All right, and so 1 over, and of course it's still cosine, sine, sine. You plug in the 135, the 150, 135, 150. Cosine of 135, that's quadrant 2, reference angle 45 becomes square root of 2 over 2, but negative. And then cosine, here the reference angle's 30, still quadrant 2, cosine of 30.
Square root 3 over 2.
But in quadrant 2. Sine of 45. Quadrant 2. And sine of 30. Quadrant 2. All right, so doing it this way that I'm initially showing, we get 1 over, here we get a negative square root of 2 over 4. Positive, because there's 2 negatives, or plus the negative gives positive, square root of 6 over 4. I'm going to reverse those and get 1 over square root of 6 plus, excuse me, minus square root of 2 all over 4. If you come up here, negative times negative gives positive, square root of 6 over 4. Here, minus a positive is negative, square root of 2 over 4. And you still end up at the same point. Okay, so again, it doesn't matter which angles you use, you get to this point, but the 1 over means reciprocal. So I've got to flip it and get 4 over square root of 6 minus square root of 2. 2-term radical denominator to multiply by the conjugate, which is?
Square root of 6 plus square root of 2.
And in the denominator, square the first, square the last, put a minus sign, I get 6 minus 2, which is 4. And I'm actually not going to distribute here, because I can just cancel the 4s, and there's my answer, the square root of 6 plus the square root of 2. How many have that answer regardless of the angles used? Okay, Quentin, good. Question, other gentlemen? All right, questions on how to find special or exact values of non-special angles using sums and differences.
We aren't going to have a quiz over this today, are we?
No, tomorrow you will have a quiz. In fact, I was going to announce that with the homework. So there is a quiz in our next lesson over these sum and difference identities. Questions? All right, let's take a look at page 116, number 8. Page 116, number 8. No, the poster will not be up for the quiz.
What do you think?
Can't just throw us a bone, man.
Nope. No bones about it. All right, anyway. I haven't heard that expression in a while. All right, page 116, number 8. We got the cosine of 135 degrees plus 120 degrees. In other words, what angle is this, class?
255.
255 minus the sine of 315 degrees minus 240 degrees. In other words, what angle is this? 75. So really, we're finding the cosine of 255 minus the sine of 75. Let's do this on the calculator real quick. I mean, there's such easy functions to use anyway. Take cosine 155, or 155, okay, 255, thank you. 255 cosine minus 75 sine equals. Let's see what our answer should be.
Negative 1.6134.
That one? All right, all of us get the same thing? I haven't plugged it into my calculator, so I don't know.
Did Jamie still have your calculator?
No, okay, so on the physics lesson, I was giving Jamie a hard time about keeping my calculator. Her mom actually emailed me earlier in the morning to let me know it was in her locker, so I could get it. And I just hadn't checked my email yet because I hadn't had any time all day. So anyway, I do have my calculator back.
Happy calculator.
I tell you, I don't have to charge her $4 or $5 now because she's out again today, bless her. So no, at least the rental isn't going up on you, Jamie. All right, anyone else watching YouTube's like, what? It's okay, don't worry about it. All right, so we come here and we see cosine, sum difference identity, class.
Oh, cosine, sine.
All right, folks, cosine sum difference identity is the cosine, sine, right? So we're going to do cosine, sine, change to a negative, sine. Of course, we'll drop in the
angles.
135.
And then notice here it says minus or negative. Now, normally for sine, sum difference, we would do sine, cosine, sine. Okay, so for cosine, it's
Cosine.
but for sine, it's
Sine, cosine.
sine, cosine, sine. Okay, so let's try this again, class. For sine, it's sine, cosine, sine. And for cosine, it's cosine, sine. So for cosine, it's cosine, sine. But for sine, it's sine, cosine, sine. So we put sine, cosine. Normally, we would keep this minus cosine, sine. But there's a negative in front of all of it. So it's going to make all of this negative. And this positive. Make sense?
Yes.
And we drop in our angles. 315, 240, 315, 240. And so we're going to have a whole bunch of small products here to multiply.
Bunch of annoying stuff.
All right. And for every one of these, we got to think through reference angle and quadrant. Well, let's start with quadrant. 135?
2.
Reference angle?
45.
45. What's the cosine of 45?
Square root of 2.
In quadrant 2?
Negative.
120 is quadrant
2.
reference angle
60.
60. What's the cosine of 60?
Negative
1/2 in quadrant 2?
Negative.
Negative. Sine of 45
Square root of 2.
in quadrant 2?
Positive.
Sine of 60
Square root of 2.
in quadrant 2?
Positive.
315 quadrant
4.
reference angle
50 or 45.
45.
50.
Sine of 45
Square 2 over 2.
in quadrant 4?
Negative.
Negative. Oh, cosine 240. Let's see, that's quadrant
3.
reference angle.
60.
All right, cosine of 60.
Negative
1/2 in quadrant 3.
Negative.
Negative. All right, cosine of 45.
Negative square root of 2.
Square root of 2 over 2 in quadrant 4.
Negative. Positive.
Positive. Sine of 60
Square root of 2.
in quadrant 3.
Negative. Negative.
All right, what are we going to multiply right here?
Square root of 2 minus square root of 6.
Square root of 2 over 4.
Sorry, whatever.
Right here, I've got minus a positive. Or we can think of this as negative, positive. That's only one negative, so my answer is going to be negative square root of 6 over 4. Come here, I've got negative, negative, negative.
Negative.
That's 3 negatives, so it stays negative.
Square root of 2 over 4.
And here I've got positive, positive, negative. It's only 1 negative.
Negative.
Negative square root of 6 over 4. So I've got a 2 square root of 2 over 4 and a negative square root of 2 over 4. Cancel. I've got a negative square root of 6 over 4 and another negative square root of 6 over 4. No.
No, you can't cancel.
Negative 2 squared of 6 over 4, which reduces
To square root of 6 over 2.
And that's our answer. Plug that into your calculator. Take the square root of 6, make it negative, divide it by 2.
1.2247.
Ooh. That's not what we got up here.
Negative.
Oh, I got it again. I did math wrong first time.
Hold on. Square root of 6, make it negative, divided by 2. Yeah, I'm getting a negative 1.2247, blah, blah, blah. Okay, let me go here and see if we got this right, because that is 255. So we have 255 cosine minus 75 sine. Yeah, y'all gave me the wrong number here. Jamie's been screaming about it this whole time. It is a negative 1.2247, blah, blah,
That's
blah.
what we get for listening to Chris. Yeah.
I asked all of you to confirm his answer. I wasn't trusting him. I was trusting y'all as a consensus to not all screw it
I
up.
feel like Biden, everything's smart about him.
I know. And really we have Kamala to blame.
Inflation?
Psaki, well, she's just the brainless mouth.
Who's that guy that went on vacation for 2 months and like the gas?
Oh yeah, her transportation guy, Buttigieg or whatever his name is.
Yeah, I feel like Buttigieg right now.
Anyway, all right, questions on this. So it does check out if just we get the right number in the first place.
I didn't realize we would have done all this and got the wrong answer.
I was like, well, if this is correct, then somewhere along the line we screwed up. And so that's why I double checked this, just to make sure I didn't redo any of this before I had to. No, y'all just got the initial number wrong. And I say y'all because y'all concurred with Chris, and maybe that was your first mistake. Anyway, let's go ahead and do a trig verification. You can close your books for just a moment. We'll get back to them in a little bit. Why don't you write this down? The sine of, let's see, I need 2 Greek letters. Quentin.
Alpha and beta.
Alpha, beta. Okay,
Oh
so
my
write this down. The
goodness. You're so
sine
boring.
of alpha plus beta. Sine of alpha plus beta over cosine alpha cosine beta equals tangent alpha plus tangent beta. We're going to verify that this is not a lie. All right? So I'm telling you this is a true identity, but you have to verify that I'm not lying to you. It's like fact-checking major news outlets and minor news outlets like OAN. Anyway, all right, so let's hit the people on the right while we're hitting people, right? Let's not just beat the left down. All right, OAN is a little fact-checking, some Newsmax, stuff like that. Anyway, all right, thoughts?
The right side is the more nasty side.
The right is more nasty?
I mean, it's my other right.
Your other right.
Stop, Ethan.
Yeah. Distribute sign.
Whoa. Okay.
Whoa, we got to tip with shit.
We aren't distributing anything. This is a sum difference identity.
Whoa.
We have a sum of angles, and we're taking the sine of the sum. So how do we actually write out the sine of alpha plus beta, class?
Sine, cosine, plus or minus, cosine, sine.
Sine, cosine, cosine, sine. And we'll drop in the alpha and the beta and the alpha and the beta. So be careful with that. Don't ever distribute. Sine of alpha plus beta does not equal sine of alpha plus sine of beta. It equals sine alpha cosine beta plus cosine alpha sine beta. Sine, cosine, cosine, sine. And then in the bottom we have cosine, cosine, but not sine, 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 just cosine alpha, cosine, boring beta. All right, someone besides Quentin, because he led us astray, though he did give us 2 great angles, though Ethan would disagree. He was going for like epsilon.
We cannot.
We haven't used epsilon yet. We should.
I don't think we should.
We
sounds like a disease.
We cannot
that's
be
epilepsy.
mistaken by thinking we can cancel anything here, because they're terms.
Right.
Who asked?
Anyway. Yeah, okay. So for instance, if I had an AX plus BY over, say, XY, what could I do?
Pull out, you can take one out. Conjugate? No, there's no conjugate.
I could look at this as dividing by a monomial. Sine never letter once.
Yep.
Sine never letter twice to get AX over XY plus by over xy, correct?
Yeah.
Let's do that here. How would I do that, Ethan?
Sine alpha cosine beta over cosine alpha cosine beta plus cosine alpha sine beta over cosine alpha cosine beta.
All right. Let me just sit down. Chris, thoughts?
Why me, man?
Because it's your turn.
Cancel cosines?
Where?
Let's do left side first.
We are on the left
It doesn't
side.
matter. It's at the left.
It just,
The far left.
the far
The
left.
first fraction.
Yeah.
Cancel the two cosine betas.
Yes.
Good. Not just any two cosines, specifically the cosine betas. So all I'm left with here is.
Sine over cosine alpha over cosine alpha.
All right. And then what?
Cancel, do the other side next. So
We are the fraction.
Yeah.
Same side, the fraction.
So this time you're canceling the alphas, not
Cosine alphas.
So then you're left with sine beta over cosine beta.
All right, Quentin.
We don't, but we have to.
Sine alpha over cosine alpha is tangent.
Oh, so
Tangent alpha plus tangent beta equals tangent alpha plus tangent beta.
we're done. It wasn't so bad after all. As long as we write the initial step correctly.
Don't
Because if we write sine alpha plus sine beta, we're toast. And if it's a, I don't know, 40-point, quiz problem,
Is this a
we just lost all 40
Just a
points.
hint?
What?
Just a hint?
I'm just giving you an example, for instance, from our last quiz. You botched that initial step. There's not a whole lot of room to save yourself. We've got to get the initial step or two correct, right? And so very, very important. All right, let's go back to your textbooks for a moment now. Page
You
116.
could technically get credit based on what we missed, but going on afterwards, if we got any of those.
There's really nothing you could have done after you missed that, though.
That's true.
So you're just done. It's sad. We cry and retake the class next year.
I was just going
Are
the
you
long
calling
way.
me out?
He's not calling me out.
He's not calling me out.
If
I thought we were picking on Quentin
If I
because
don't
he's the
pass
one who
this year, I'm
suggested
dropping
sine
out.
alpha, sine beta. I don't know.
I was going the long way. I know what you're
Roy.
The wrong way. That's
I was going the wrong way.
Roy.
the long way with the Chinese accent. The wrong
Yeah.
way.
Say the wrong way.
That's not
It's
racist.
a
All right.
Soviet Union, the wrong way.
So anyway, all right. Let's take a look at number 15. Let's do tau and kappa. We are given that the cosecant of tau is -3/2 in quadrant 3.
Is this whole period just practicing?
We're also told that the tangent of kappa, well, considering there's a quiz tomorrow, I would suggest probably, the tangent of kappa is 4/3. That is also in quadrant 3. The question is, what is the sine of tau plus kappa? Now, if you were to add a quadrant 3 angle, picture one in your mind, plus another quadrant 3 angle, obviously that's going to be bigger than 360, right?
Mm-hmm.
What quadrant would it be in?
2.
Possibly.
Or possibly 1 as well.
Good. Either quadrant 3 or quadrant 1. For instance, if you take a couple of small quadrant 3 angles, like say 190 and 190, that would add up to 380, wouldn't it? Which would be quadrant 1, because it's a 20-degree angle, really. But if you take a bigger angle, like say 250 and 250, well, that adds up to 500, which subtracts your 360. That puts you in quadrant 2. So this sum, tangent plus kappa, is either quadrant 1 or quadrant 2. I don't know what the actual angle is. I could find it, I suppose, on the calculator. I don't care that much. But I'm curious what quadrant it'll end up in. And it depends. If my sine comes out, no, it'll be positive no matter what, won't it? I guess we'll have to wait for the cosine to figure out what quadrant we're dealing with here. But anyway, for now, we're finding the sine of tau plus kappa. And what we should always do when we see sine of a sum or difference, we don't distribute, we write.
Sine, cosine, plus, minus, cosine, sine.
How about just sine, cosine, cosine, sine?
Okay.
And we keep whatever the SIGN is, because that's a lot easier to say.
How about we just do this?
Let's do that. So do that at your seat. Sine tau, cosine kappa plus cosine tau sine kappa. And we need to plug in our numbers. Well, we know what the sine of tau is. It doesn't expressly say it. We can do it really easily in our heads.
4.
Oh my.
Oh my.
The cosecant of tau is -3/2.
Okay.
What's the sine of tau?
Negative 2/3.
-2/3. The cosine of kappa is going to be a little different, because here the tangent, of course, which we know is 1 over what?
4 over 3.
Which
Sine
is,
over cosine.
oh, how about opposite over adjacent? We're doing the easy way.
Okay.
Tangent's opposite over adjacent, right? But cosine is adjacent over hypotenuse.
Oh, right.
Oh.
So we know the adjacent's going to be a 3. But we don't know the hypotenuse
5,
yet.
4.
It's going to be 5, because it's a 3, 4, 5 right triangle. And kappa's in quadrant 3. So cosine of kappa should be negative. Just since cosecant in quadrant 3 is negative, so sine in quadrant 3 is negative. All right, let's come to the cosine of tau. Now again, we don't know the cosine of tau. We know the cosecant of tau, which is 1 over what?
Hypotenuse over opposite.
But we need the adjacent. What's the adjacent?
3.
4. Hold on.
5 for the
Square root of 5.
25, yeah.
Quinn's smart. He doesn't want to make it sound stupid.
So cosine of tau should be adjacent over hypotenuse, but in quadrant 3, cosine's going to be
Negative.
so negative square root of 5 over 3. And then we need the sine of kappa. We'll come back to kappa down here. What's the sine going to be?
3 over 5.
Opposite over hypotenuse?
4.
4 over 5. But in quadrant 3, sine is
Negative.
so negative 4 over 5. So remember this and finding other trig functions? We're still doing that. But we're incorporating it into a sum difference identity now. Everything kind of comes together at once. And so we multiply. This isn't too bad, right? Negative 2/3 times negative 3/5 gives
Negative 6, or positive 6 over 5.
positive 6
15.
15. Now you say, well, I could reduce that. You could, but you don't want to, because look what's coming. Plus negative negative, or in other words,
Positive.
positive.
4 times
square
square
root
root
of
5
5
over
over
15.
15.
And, well, I guess we're stuck by writing 6 plus 4 squared root of 15, or 5, excuse me, all over 15. And that's the sine of tau plus kappa.
Okay, that's it. That's all we got.
That's it. Now, I suppose if we really wanted to, class, we could figure out what this actually is. So on your calculators, since I know that the sine of tau is negative 2/3, then tau must be the arc sine of negative 2/3. Take the arc sine of negative 2/3.
Negative 41.8.
Now, the negative 41.8, we're going to talk about this more in the next chapter. Yes, the next chapter. But if we were to take off the negative sign and add 180, it would give us 221.8 blah, blah, blah. Put that in the memory of your calculator. Let's come here. We know the tangent is 4/3, but it's in quadrant 3. So take the arctangent of 4 over 3.
53.13.
But add 180 to that.
233.13.
All right, now, put that in memory 2. Now add memories 1 and 2 to get what new angle?
454.9.
454.9, blah, blah, blah. Put that in memory 3. Take the sine of memory 3.
0.996.
0.996, blah, blah, blah. Now, 6 plus 4 times the square root of 5. I would start with 4 times the square root of 5. Square root of 5 times 4 plus 6. Divide that by 15. Do you get 0.996?
Yes.
Wait, do say one more time.
Square root of 5 times 4 plus 6 divided by 15. Yep, there's the 0.996. It checks out.
Yep.
That's if you really wanted to figure out what the actual angle is. It's a 454.9 degree angle we're dealing with here. So, by the way, the next part of the problem says to find the cosine of tau plus kappa. Go and take the cosine of memory 3.
Negative.
0.086.
I get positive.
I had negative.
Negative.
Negative, yes, you're right. I have negative 0.0861, blah, blah, blah. Okay, I'm just going to write that number up there because that's what we should get for our answer for cosine tau plus kappa. By the way, we can tell that this angle is slightly into the second quadrant, isn't it? Because 360, 450, 454 is just barely making it that second quadrant, which is why cosine came out slightly negative, because it's slightly into the second quadrant where cosine is negative. All right, for cosine, anytime we see cosine of a sum or difference, cause we need to write
Cosine, cosine, sine.
That's not making that weird.
all right, with the tau and the kappa and the tau and the kappa. And the good news is, we've already found the cosine of tau to be negative 5, square root of 5 over 3. So we're not redoing nothing, right? And we already found the cosine of kappa to be negative 3 over 5. Minus. And we found the sine of tau to be negative 2 over 3. And we found the sine of kappa to be negative 4 over 5. So all the hard work was done in part A. Part B is easy. And we just reap the benefits. So when we multiply here, we get
3 square root of 5 all over 15.
negative, negative, negative gives me a negative 8 over 15. I'm just going to extend the fraction bar. Let's do this on the calculator. 3 times the square root of 5 minus the 8 divided by 15. And sure enough, there's the negative 0.08611, blah, blah, blah.
Wait, what? Wait.
Yeah.
3.
Square root of 5 times 3.
I got it.
Minus 15.
He didn't even touch his calculator. All right, questions on this?
He doesn't even know how to use that calculator.
All right, now we come to the
Yes, I do.
tangent of tau plus kappa. Tell you what, on your calculator, take the tangent of memory 3.
Oh my goodness.
This should also be negative because we're in quadrant 2, right?
I have 89.87.
89
I
point.
had negative 11.
Should be negative though,
I
right?
don't have a negative.
Memory 3. Hold on.
Big arctangent.
What do you have?
Negative
Tangent? Or arctangent? Tangent.
I got negative 11.568.
Yeah.
Oh, you had to take tangent? I thought it was arctangent. My bad.
You're
All right, so negative 11.568, we like that value. See, we
Yeah.
gotta stop listening to Chris. All right, how do I find
everyone in this group?
tangent of tau plus kappa? What do I do anytime I see tangent of a sum or difference?
Tangent plus or minus tangent, 1 minus or plus tangent tangent.
What?
Roger.
Tangent plus tangent all over 1 minus tangent tangent. Unless it were a minus, then it'd be tangent minus tangent over 1 plus tangent tangent. And we're dropping the tangent and the kappa and the tangent and the kappa.
Big cap.
And that would be from the little battle droids, right, in the earlier story.
Roger.
All right, anyway. All right, so the problem is I don't know the tangent of tau.
4 or 3.
But, that's kappa. I don't know the tangent of tau. But since I know it's in quadrant 3, I know it's going to be positive. And since I know that tangent is opposite over adjacent, I know I'm going to get
2 over square root of 5, which is 2
square root
times
of
square root of 5 over 5.
I'm just going to leave it as 2 over square root of 5 for a minute.
Oh,
Because
come on.
I got a feeling it might be easier if I do it this way.
Oh, that's right.
All right, and that's positive. Plus, I knew the tangent of kappa,
Or
4/3, which is happy. All over 1 minus, and now I need a tangent of tau, which we just wrote down,
2 over square root of 5.
and tangent of 5. Tangent of kappa.
4 plus 3. Or 4 plus 3.
4 plus 3.
All right, I'm going to have to do some erasing here, get this out of the way. All right, and so let's come up here now. And this, when I multiply, this is the only time I actually have to multiply. What do I get?
1 minus
6 over 5.
8
over 3 times square root of 5.
Square root of 5.
8 over 3 square root of 5,
Yeah.
right?
Yep.
Which means I'd be well served to rewrite my 1 how?
3 square root of 5 over 3 square root of 5.
So far, so good?
Yeah.
All right. And then you're doing this with me, right?
Yes.
And then in the numerator, we need a common denominator. And between square root of 5 and 3, what's the common denominator? 3 square root of 5.
Yeah.
So here multiply top and bottom by
3 times
3 to get 6. And here multiply top and bottom by
square root of
5.
to get,
4 times square root of 5.
by the way, there we go. Now notice, both of these have the same denominator, 3 square root of 5. So when I multiply by the reciprocal, this is going to move to the numerator, it's going to cancel. And this is going to move to the denominator. So really, I have 6 plus 4 square root of 5 all over 3 square root of 5 minus 8. You still following the algebra, or we need to slow down and re-explain?
Okay, I got it.
We're all good?
I think so.
All right? What do we got to do now?
Multiply by conjugate.
Multiply by the conjugate. What's the conjugate?
3 square root of 5 plus 8.
3 square root of 5 plus 8.
My paper is not looking too good right now.
All right, in the denominator, square the first square, let's put a minus. And be careful, what do we get when we square the first?
9
times 5, which is 45. Square the 3 to get 9, square the square root of 5 to get 5. 9 and 5 is 45. Square the last to get?
64.
That's easy, put a minus sign. So what's my denominator going to become?
19.
Negative 19.
All right, in the top, I'm going to have to FOIL. What am I going to multiply my first?
18 square root of 5.
Outer. 12 times square root of 25. That's going to be 12 times 5 is 60. We follow?
Do that again.
3 times 4 is 12. Square root of 5 times square root of 5 is square root of 25. That's 12 times 5, which is 6. You know, it's a good thing you asked because people on YouTube may have that same question. The inner is easy.
42.
48. Oh, I thought it was easy. And then the last.
32.
32 times square root of 5. So we can combine the 60 and 48 to get
108.
108. And we can combine the 18 square root of 5 and 32 square root of 5 to get
50 square root of 5.
All right, here's the moment of truth. On the calculator. 108 plus 50 times the square root of 5. Divide all of that by negative 19. And boom, there it is. Exactly what we said we should get.
Yep.
Questions on number 15?
Well, I got the math wrong. Plus 50 times
5 square root.
root equals divided by 19 negative. Got it.
Questions on this?
Can we never do one like this again?
Oh, and you want to do another one. All right, number 14. Let's take a look.
That's just
Now, what are we given in number 14?
What I said.
What are we given in number 14 here?
Cotangent of alpha is negative 24/7.
And
Secant of omega is 13/12.
And there's quadrant 4, this is quadrant 1. And we're asked to find the sine of alpha minus omega. All right. Well, anytime I see sine of a sum or difference, I should write?
Sine, cosine, cosine.
Let's try that in unison, class. Sine, cosine, cosine, sine. Again, sine, cosine, cosine, sine. And so we write that down with all the alphas and omegas in there, right? So we have sine, cosine, minus cosine, sine. I'm going to drop in the alphas and omegas. Here's the problem. I don't know the sine of alpha. I know the cotangent of alpha, though, is cotangent is 1 over what?
Adjacent over opposite.
Adjacent over opposite. So I'm missing the hypotenuse. Find it. Comes out evenly, I believe. It's an integer.
Really?
Really?
Forsooth.
25.
25. All right. Remember, it's in quadrant 4. So we already know the sine of alpha is going to be negative. What is the sine of alpha? 7 over 25. All right. We need the cosine of omega. Well, that should be easy because I'm given the secant of omega, so all I have to do is flip it to get
12 over 13.
12 13ths. And it's in quadrant 1, so it's automatically positive. Minus, I need the cosine of alpha.
24 over 25.
Quadrant 4, positive 24 over 25. And I need the sine of omega. Well, secant's 1 over what?
Hypotenuse over adjacent.
So I'm missing the opposite, which is also an integer. Gotta love when they're integers. 5. And so the sine is?
5 over 13.
And quadrant 1, everything's positive, right? So we multiply. Negative 7 25ths times 12 13ths. You could actually do this on your calculator.
84 over
325.
what? That's not right.
Negative 84 375ths.
325.
325ths. How about that? All right, then negative 24 25ths times 5 13ths. Well, if you do it on the calculator, it's going to reduce it for you.
Yeah.
So how about we leave negative 120 325ths? But, you know, even if it reduced it for you, right, to give you negative 24 65ths, the calculator can still subtract these together. Negative 84 3/25 minus 24 65 gives you, actually let's write the answer this way. I'm getting a negative 108 3/25,
36
negative
over
204,
I got 36 over 325.
negative 204 3/25,
Negative 36 over 325.
negative 36.
I got negative 36.
Negative 36 over 325.
They're both negative. Negative 84 3/25 minus 24 65.
Positive. That's negative 204 over 325.
That's what I got. There we go.
Come on, guys.
All right, let's take a look at the next part, which is to find the cosine of alpha minus omega. Well, anytime I see cosine of a sum or difference, I should write, say it slowly with me.
Cosine, cosine, sine, sine, sine.
And we drop in the alphas and the omegas and the alphas and the omegas. Again, the nice thing is, all cosine uses are sines and cosines. All sine uses are sines and cosines. So we've already found all of these. We just found the cosine of alpha to be
Negative 7 or
24.
24 25.
yeah.
You just have to find where it is in the lineup, right? The cosine of omega,
12 over 30.
12 thirteenths. We found the sine of alpha to be
Negative 7 over
negative 7 25ths, and the sine of omega,
5 over 13.
5 13ths. We multiply 24 25ths times 12 13ths.
325 is the denominator.
It is 325 in the denominator.
288.
288, 3 25ths. Positive, negative, positive gives me a minus 35,
Over.
3 25ths. And when we subtract, we get
243, 253.
253, 3 25ths. Now we're going to cheat the system. You ready for this? The tangent of alpha minus omega is going to be the sine of alpha minus omega over the cosine of alpha minus omega, right? You mean negative 204 3 25ths over 253 3 25ths? So in other words, negative 204 253rds. Questions on this? Now again, we ditched the calculator usage as far as like finding what the actual angles were and all that nonsense we did last time. That was just kind of for verification's sake, which I guess we could have done here, didn't want to. But questions on this? Homework this evening. In preparation for your quiz, I've got 3 problems for you. You're going to find the cosecant of 15 degrees, you're going to find the cosine of 195 degrees, and you're going to find the tangent of 285 degrees. That's your homework quiz in our next lesson. Over your sum difference identities, have them memorized, be able to use them. Make sure you write them correctly. Don't distribute. It's like, I wouldn't even think of that. I don't know what kind of idiot would think to distribute that.
Are we still recording?
We are. All right. Jamie, get feeling better, and we will see you whenever you return.